Hi guys, this is EPROM Experimentation Part 4 and I'll get into EPROM writing in this video. Where we left off in the last episode, I had an assembly that could read an EPROM to file and also had a power supply for the device with 3 different voltage rails, the programming voltage, the DSPIC 3.3 volt and 5 volt for logic, and I'll finish that off with the heat sinks here. There's different potentials on these tabs, so they have different heat sinks. To start off with, my programmer only had a dual wipe IC socket, and since I only want to program for this 1 meg EPROM with 42 pins, I want to customize a ZIF socket, which are hard to come by, so I've modified a 40 pin ZIF, taken to it with a Dremel, and it worked out quite nicely. Initially I've used a bit of copper here. You only need to attach a connection to one of these pins, because one's not connected at all inside the chip. And ripping apart another ZIF socket, I've got a fully working clip inside there, the brass terminal that moves. So I'm quite happy with that. When I get some acrylic solvent, I'll wedge a few small pieces of plastic in it and I'll have something that's quite workable. At this stage, before getting the hardware ready for writing an EPROM, which basically involves supplying the programming voltage, I've done the verify routines, which verifies against a source file, and this one here is showing blank checking, so there's a blank checking routine as well. On the board to the right, where there's a single green LED, there's also a red LED that only lights when something goes wrong, which is a blank check failing or a verify failing.
Oh, that's backwards.
Now for writing the EPROM, I'm powering my power supply with a 16 volt supply overall to be sure that it can provide a 12.5 volt programming voltage. I'm only switching that manually, all other lines are software controlled, and this is actually my first attempt at programming EPROM, and I didn't know at this stage whether I'd be successful or not. This is in situ, so forgive the video quality. It wasn't successful the first time, the first pass. There were some bits that were supposed to be cleared that remained set, but I did it in about 3 passes. I was just using fixed timings, so there's no write verify that you're supposed to do yet. But yep, I got there. So I've used some copper foil to cover my first EPROM. I've mentioned in previous videos the point behind this is to replace the stock ROM in a CD32 with a custom one, and this is what the CD32's interface looks like for its audio CD player. And with the new ROM, you can see that the interface is different. The infrared remote control is another project on my channel. I'm showing you the display here. You can see that it's clearly different, and it's playing a Yothu Yindi CD, which I'm cleverly covering with my voice to try and avoid the copyright detectors finding it. It is quiet enough anyway, so that I don't think it'll be a problem. Now, rather than reprogram the microcontroller every time I want to change a mode, I've made a parallel shift register button board just to save one I/O pin on the microcontroller. It would have taken 4 pins to use 4 buttons directly, but with this I've got it down to 3. What a saving. I meant to show some software on this video, but we had a power blackout for 5 hours with scheduled maintenance, and I needed to get this footage off my phone anyway. That'll have to wait till the next video. The very next video will be about the CD32 debug board, which I'll title appropriately to appeal to the Amiga crowd, and then there should be another final one about this project. It's a priority now to get this programming voltage software controlled, which my first try is going to be using this Texas Instruments H-bridge controller. The project is starting to look like one of mine. Looks like something I'd make, a big mess. So one of these boards, the one with the SD card on it, eventually goes underneath the stack. So that's why I needed an interface with buttons, and the 2 LEDs there replace the LEDs on the bottom board, the OK and the error LED. This bottom board has to be accessible for now so I can access the microcontroller for reprogramming, and also in terms of hardware I'm doing the programming voltage control in hardware on the same board. So hopefully this works. If you're here watching this from one of the Amiga groups, the CD32 debug board video will be up next, so hopefully the IDE port now works and controls a hard drive with the new ROM in the Amiga. For electronics people, the video after that will go into a little bit more detail about some of the things I glazed over in this video. Alright, catch us next time.